All right, in this last section, we are going to look at normal distributions. Normal distributions are sometimes called a bell-shaped curve or a bell curve, or you will hear the word or read the words normally distributed. And so what that's going to mean is a very certain case happens. You can see this chart over here with the normal distribution. With our normal distribution, you are looking for an average, which I have here, X bar. That's going to be the mean. And then so many standard deviations away. So you can see here I already have the colors. This is going to be 1 standard deviation minus 1 standard deviation plus 1 standard deviation from the mean. Same thing to 2 and 3. This is going to be plus another standard deviation minus another standard deviation. And what this means is that a certain percentage of the data will fall between these points. You do not have to memorize this. This table will be given to you. You just have to know how to find it. So here, within this part of the bell curve, there is 34% to the left of the mean and 34% to the right. So if you're looking at between 1 standard deviation, plus or minus, that's going to give you that 68%. Same thing with the next part, except this has 13.5% of the population. And then 2.4 and 0.1. Okay, so let's look at this in an example. I think it makes more sense because you'll actually be given these means and standard deviations. You will then have to set up your own normal curve and then use that to solve the problem. Okay, so here's my first example. When a standardized test score was scored, there was a mean of 500. I'm going to go ahead and underline that. There was a mean of 500 and a standard deviation of 100. Suppose 10,000 students took the test and their scores had a bell-shaped distribution. You cannot assume that it's a normal distribution. They do have to tell you. Now, in our case, they will only use normal distributions because we haven't learned any other, but it is not something that can be assumed. And so the first thing I need to do is just set up a bell curve with my numbers. So I'm going to sketch my bell curve over here. Doesn't have to be perfect. Right down the center is always going to be the mean. And so in this one, it told me that the mean was 500. And then what the standard deviation means is that's how I'm going to count. So to the right is going to be plus 1 standard deviation. But in this case, a standard deviation is 100. So it's going to be plus 100. So I'll have 600, 700, 800. And we only need to go 3 standard deviations out because past that is very, 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 very unlikely. And then to the left, I'm going to subtract 100. So here I added 100 because that was the standard deviation. Here I'm going to subtract 100 because that is the standard deviation, and I'm going to the left. So I've got 400, 300, 200. Okay, so the first thing I need to do is place my test scores on the normal curve. So here's that part. I've got my mean, which is right in the center. That's X bar. And then all of these are 1, 2, and 3 standard deviations away. And I count by whatever unit they told me was the standard deviation. All right, so now from there, I'm set up to answer my question. So the first one, letter B, says, what percentage of students scored between 400 and 600? So I need to find those on my chart. Well, 400 and 600. Those are within one standard deviation. So according to my chart, 68% of the total should fall within 400 and 600. And then the question just said, what percentage of students fall between that number? Well, 68% of students fell between 400 and 600 because it is one standard deviation away. That's what the normal curve. All right, letter C says, how many students scored between 400 and 600? Well, those questions sound very similar, but letter B said what percentage. Letter C says how many students. And so now what I'm looking for is what I just found, 68% or 0.68 times the total number of students, which it told me that 10,000 students took the test. And then when I multiply those two, 68% or 0.68 times 10,000, I'm going to get, not dollars, 6,800 students scored between 400 and 600. Now the next one says, how many scored between 300 and 700? So I'm going out one more standard deviation, 300 and 700. The bell curve says that now 95% will be between 300 and 700. But it didn't say what percent, it said how many scored between 300 and 700. So I'm going to use the percent from my graph, 0.95 times the 10,000, which is going to give me 9,500 students scored between 300 and 700. And then the last, how many students scored above 800? And so above 800 is just going to be this little tiny part right here. And according to my bell curve, that is 0.1%. So I've got 0.1% or 0.001, move that 2 spots to the left, times my 10,000, because that was the total amount that took it. And that is just 10 students scored above 800. All right, let's skip to number 2 and just look at one more example. So number 2 says, assume a normal distribution. I can't assume it unless it tells me, so that just tells me it will be the bell curve. And that the average number of texts per day is 22. This is very old. The average number of texts per day is 22, so that's going to go right here in the center of my bell curve, with a standard deviation of 3. So what that means is I'm counting plus 3, plus 3, plus 3. So I'm going to go from 22. 25 is going to be one standard deviation up. 28 is going to be another standard deviation or 2. And then 31 is going to be 3 standard deviations. Going to the left, I'm going to subtract. So I'm going to have 19 is one standard deviation, 16, and 13. Now I'm going to go back to my question. My question says, what percentage of people received 16 texts per day. So here is 16 on my bell curve, and I'm actually going to change this and say what percent of people received less than 16 texts per day. So here is that area I'm looking at. And if I go back to this part, let's first count. I am 1, 2 standard deviations to the left. So I'm going to go to my chart, and I'm going to go 2, 1, 2 standard deviations. So this is the area I'm looking for. Well, I know that this is 2.4, and this is 0.1. And so if I'm looking for that whole region, I can add those two together and say that this area right here is going to account for 2.5%, because it was 2.4 plus 0.1 is going to give me that 2.5. And so what percentage of people received less than 16 texts a day? 2.5%. What if it had said, let's make a new problem. What if this had said, what percentage of people received more than 25 texts per day? Okay, well, I would go to my normal curve that I set up, 25, and I'm looking for more than 25. So I'm looking for that whole area. Well, I'm 1 standard deviation away. So let's go back and look at my percentages. I'm 1 standard deviation away. So I've got 13.5, 2.4, 0.1 that I need to add up. Got, 13.5 is to here. The next one is going to be 2.4, and then 0.1. And so I'm going to add all those up and get 16%. So you just have to pay attention to what the question asks, and is it looking for between two numbers, or is it looking for less than or greater than? But that gives you two examples, one with between and then one with greater than and less than. You do need to understand how to use this. You do not have to have it memorized because I will give it to you, but you do need to understand how it works.